All right, so if you're a developer, you've definitely felt this pain. You've got a powerful AI coding assistant, but the moment you throw it at a big, complex codebase, it just gets lost. Well, today we're going to dig into why that happens and talk about a real shift in how AI can finally understand our code.
I mean, this right here from a developer on Reddit just nails it, doesn't it? We have these incredible LLMs, but on any real-world project, they just seem to stumble. They get tangled up in all the functions and classes, and you end up with these clumsy changes that break more than they fix.
And here's the thing you gotta understand. The problem isn't that the AI isn't smart enough. It's a vision problem. The AI is basically working blind. It can read the words in a file, sure, but it has no idea how that file connects to everything else. It can't see the map of your code. Now, the go-to solution for this problem has been something called Retrieval Augmented Generation, or RAG. But as we're about to see, when it comes to the kind of precision you need for software development, RAG is really just a shot in the dark. So at its core, RAG is basically a souped-up Control+F. It uses semantic search to find code snippets that look or feel similar to what you're asking about. But similar isn't good enough in code, right? You don't need the function that looks like user.validate, you need the exact one. RAG just kind of guesses, and that's where things go wrong.
This breakdown really shows the night and day difference. RAG's semantic search is like trying to understand a city by just reading random street names. It's slow, and you're going to get lost. Structural indexing, on the other hand, is like having a full 3D map of the entire city. It knows the whole dependency graph, which means it can get you to the exact definition instantly and precisely. It's the difference between guessing and knowing.
Okay, so if RAG is the wrong tool for the job, what's the right one? Well, this is the cool part. The answer has been right under our noses for years, powering all the best features in our IDEs, like autocomplete and go-to-definition. It's the Language Server Protocol, or LSP. And this is the secret sauce for giving AI real context.
You see, LSP isn't a search tool, it's a map maker, a code cartographer. It doesn't just read the text, it analyzes your entire codebase and builds a complete index, a dependency graph of everything. It knows exactly where every function is defined, where every variable is used, and how it all connects. It creates the very map the AI has been missing all along.
And this control-click analogy is absolutely perfect. Think about it. As a developer, you do this 100 times a day. You see a function, you hit control-click, and boom, you're instantly at the definition. That's LSP working its magic. A tool like Serena gives that exact same superpower to an LLM. The AI stops guessing, it just clicks through the code with perfect precision. And yeah, this reaction from another developer really says it all. The second you connect those dots, it's just this aha moment. It's so simple, it's genius. You're just handing a proven, professional-grade tool to the AI.
Okay, so this sounds amazing, but I know what you're thinking, especially if you're in DevOps or work with any kind of proprietary code. How is this secure? Is my code being sent somewhere? And that's a huge question. It's solved by another key piece of the puzzle, the Model Context Protocol, or MCP. What's so crucial about MCP is that it's an open standard that acts like a secure bridge, but only on your local machine. It allows a tool like Serena, which has that LSP-powered map of your code, to talk directly to an AI model that's also running on your machine, like the Claude Desktop app. It makes a completely private, air-gapped workflow possible. And this slide spells out the #1 benefit for any serious developer or organization. Your code never, ever leaves your machine. It's never sent to some third-party API. It all runs locally, you plug it into a local model, and you keep 100% control and privacy over your own IP. That's a game changer. So let's talk about the practical payoff here, because this doesn't just work better, it completely flips the script on how much powerful AI assistants should cost. And here's the kicker. Because Serena is open source and this whole setup runs on your local machine, what do you pay for API calls? For monthly subscriptions? Zero. Absolutely nothing. It's a powerful and totally free alternative to all those expensive services out there. So let's wrap up the advantages. The AI's changes become surgical, small, precise, and correct because it has the full map. This also saves a ton of tokens because you don't have to stuff the context window. It's open source, built by devs, for devs.
And yeah, for a lot of what you do day to day, it can straight up replace those paid Copilot subscriptions.
And getting started is really straightforward. You just install the server, hook it up to your local AI model, let it do its thing, and index your codebase, and that's it. You're off to the races, coding with an AI that actually sees your project the same way you do. So I'll just leave you with this to think about. If your AI doesn't have the map of your code, is it really a copilot that's helping you navigate? Or is it just a passenger looking over your shoulder and guessing which way to turn?